All right, so the only topic left in our organic chapter here are organohalogens. So, considering we actually already did that in chapter 8, this should be pretty easy. You guys learned how to name products that were organohalogens like this 2-chlorobutane, right? Or maybe even this 3,3-difluoropentane, or even possibly this fluorobenzene, right? So we already know what these look like and we've named them even. So shouldn't be too tough to pick up on this. There's just a few details that we need to add in. So again, we named these already, so we should know how to do it. But IUPAC names are different than common names. So that's the one little thing that we might go over real quick, because I have two different possible names for this compound, right? We learned that we could call it a chloroethane. Oops, excuse me. We know that that would be an appropriate name for it. I could put a 1 or not put a 1, doesn't really matter in this case, because there's only one possible chloroethane. But a new name for this, a common name for this, would be ethyl chloride. It'd be kind of like using a common name for an alcohol or for a thiol, where you can just say that branch name. So this is a 2-carbon branch, ethyl chloride, right? So you can use our old names, chloroethane, or you could call it ethyl chloride. Either way, you give me enough information that I can tell what it is, they're appropriate. So again, you just have options now. That's the only thing that changed from before, is now A, you have to name them. It's not just optional. And B, you have a new version of a name that you can use. You could call it ethyl chloride as well if you wanted to use that common name. So again, if you had a different example, this could be called a 2-fluoropropane, or I can call it an isopropyl fluoride. The only times that you can't use a common name is for something like this. This would be a 2-fluoropentane, but I don't know what this is called as a branch, right? I don't have a name for that. It's too complicated to name. So I would probably just not use a common name for this one. I just go with the IUPAC. Pen's being, oh, that's weird. That was fun. Let's undo that. So I just go with the IUPAC name for that. Instead, I'd call it the 2-fluoropentane. The other exceptions that you need to know, the things that are on this slide: methylene chloride, chloroform, carbon tetrachloride. A methylene chloride is actually a carbon that has 2 hydrogens connected to it, but also 2 chlorines. So that's just a common name for that thing. It's a common enough chemical that it just, people use this name. But what we would probably call it, again, if it was an IUPAC name, would be a dichloromethane, right? Again, kind of a weird name, but methylene chloride, dichloromethane, go with whatever you want to go with, right? Otherwise, chloroform, you've probably heard of that before. Only has 1 hydrogen, and it's got 3 chlorines attached to it. Its IUPAC name would be trichloromethane. I'm assuming you probably don't need me to write that. So chloroform, probably heard of it, in the movies at least, how you put that on a rag and then put it over somebody's face and then knock them out. It actually is an anesthetic. It will actually knock you out. But again, not necessarily the safest thing to do, so I wouldn't suggest going out and do that, although it'd be kind of hard to get a hold of chloroform. So it's not as frequently as occurring as a movie might suggest. But then that last one, a carbon tetrachloride, again, that's actually a name we've used before. That just means I have one carbon and 4 chlorines, right? Which, again, IUPAC-wise, that'd be a tetrachloromethane, right? And again, this is from before. We've done that in the past. Our naming for binary compounds, 1 carbon, 4 chlorines. We call it a carbon because we don't say mono for the first word. Tetra meant 4. Tetrachloride means there's 4 chlorines in this molecule. Again, it'd be the same as the other ones if I drew it out, if I expanded it. It'd just be surrounded by chlorines now, that carbon would be. But again, some common names are not just branch and then anion version for that halide, whatever it happens to be. Sometimes they're a little bit different. But should be pretty easy to pick up on those. You might have to do the methane, chloride, chloroform, carbon tetrachloride on a worksheet, but those may or may not end up on a test. Just make sure you know how to name your compounds, like this compound over here, again, isopropyl fluoride or 2-fluoropropane, whatever you want to call it. Otherwise, our properties, weakly polar or nonpolar. Again, actually, fluorine's very, very electronegative, so those molecules would likely be more polar. And then they might be soluble in water, but it depends on how many carbons are attached to this thing. Right? The more carbons you have, the more carbons and hydrogens in the molecule, the more likely it is to be nonpolar and not soluble in water. Otherwise, they do make good organic solvents. They just happen to be toxic, which is unfortunate. You wouldn't want to use them then. They're relatively uncommon in living things, right? Unless you happen to be using it. As an anesthetic, right? But then a doctor's controlling that and making sure that they don't hurt you, right? Again, we just talked about a second ago how chloroform, one of the properties that you may have already known about it was that it can knock you out, right? But otherwise, they are used in synthesis reactions. We used them before in alkylation of aromatic hydrocarbons. Remember, if I had a benzene ring and I wanted to add a branch to it, let's say I want to add that isopropyl branch to it, right? This was our reaction that we used to make that work. So if I want to make a new chemical, I might use these organohalogens, right? And I probably would have a byproduct here. If I'm being completely accurate, I also would have needed a catalyst here. I think it was aluminum chloride, but I'm not sure. Otherwise, you get the gist of it, I think. And that's it for the chapter, actually. So